36,037 feet. That is how far down the Mariana Trench goes. Deep enough to drop Mount Everest into it and still have more than a mile of ocean sitting above the peak. Only 30 people in all of human history have ever made it to the bottom. You know how many astronauts have walked on the moon? 12. 12 people walked on a completely different celestial body 238,000 miles away, and we still sent more of them up there than we've sent down to the deepest point of our own planet. That tells you something. That tells you a lot, actually. In this video, we are going all the way down. We are talking about what Jacques Piccard and Don Walsh found in January of 1960 on humanity's very first descent, what James Cameron discovered when he went alone in 2012, and what Victor Vescovo saw on his record-breaking 14 dives in 2019, including something that had absolutely no business being at 35,000 feet below the surface of the ocean. We are covering creatures that thrive in total darkness, under pressure that would crush a submarine like a soda can, underwater volcanoes leaking liquid carbon dioxide and molten sulfur, and discoveries made in 2024 that genuinely rewrote what scientists believed was possible for life at extreme depth. And if you have ever wondered what it means that we have mapped more of the moon's surface than our own ocean floor, this video answers that, with real numbers, real expeditions, and findings that will change how you look at the planet you are standing on. Right now, if this is already sparking your curiosity, do me a favor and hit that like button right now and subscribe to the channel. It helps more people find videos like this, and we have a lot more deep ocean content coming that you will not want to miss. All right, let's go to 36,000 feet. Most people picture the ocean floor as flat and sandy and basically boring. The reality is it is as dramatic as any landscape you have ever seen on dry land. Mountain ranges, active volcanoes, enormous plateaus, and one massive planet-splitting scar. The Mariana Trench sits in the western Pacific Ocean, roughly 200 miles east of the Mariana Islands, which is the archipelago that includes Guam. It curves in a crescent shape, about 1,580 miles long and 43 miles wide on average. Just to put that in terms, you can actually feel 1,580 miles is roughly the distance from New York City to Miami, and then keep driving. The trench exists because of a collision. Two massive tectonic plates, the Pacific Plate and the smaller Mariana Plate, are moving toward each other constantly, with the kind of slow, grinding patience that only geology has. The Pacific Plate is older, heavier, and denser, some of it up to 180 million years old. And it is being forced down and underneath the Mariana Plate in a process called subduction. As that older crust bends downward, it creates a depression so extreme, it becomes the deepest point on the surface of the entire planet. At the deepest end of that depression sits a narrow, slot-shaped valley called Challenger Deep. The most precise measurement we currently have, from a 2021 study using pressure sensors, puts it at 35,876 feet, or 10,135 meters, with a margin of error of just 20 feet. Earlier estimates ranged from 35,756 feet all the way up to 36,000 to 70 feet, depending on whether researchers used sonar, sound pulses, or direct instruments. The 2010 NOAA measurement using sound pulses through the water column returned 36,070 feet. Scientists keep refining the number, but not one measurement has ever brought it shallower than 7 miles straight down. 7 miles straight down. What makes the Mariana Trench deeper than every other trench on Earth is a combination of factors lining up almost perfectly. The Pacific Plate at this location is ancient and extraordinarily dense and cold, so it sinks steeply rather than gradually. The area is also far from major rivers, which means very little sediment has filled the trench in over time. And nearby fault lines cut the Pacific Plate into a narrow tongue shape, allowing it to bend more sharply than at other subduction zones. The Mariana Trench is basically the geological jackpot of every variable conspiring to create maximum depth. The Mariana Trench Marine National Monument was established in 2009, protecting 246,610 square kilometers of submerged lands and waters. But here is a quirk worth knowing. Challenger Deep itself sits just outside the monument boundary and falls within the territory of the Federated States of Micronesia. Research permits are required to operate there, and the site is jointly managed by the U.S. Fish and Wildlife Service and NOAA. So the deepest point on Earth has paperwork. Bureaucracy goes all the way to the bottom, apparently. Now, back to where this story actually starts, which is 1872. The British Royal Navy launched a ship named HMS Challenger on what became the world's first dedicated global oceanographic expedition. For 4 years, from 1872 to 1876, the vessel crossed and recrossed the oceans dragging weighted lines, called sounding lines, to measure depth. Then in 1875, somewhere in the Western Pacific, the crew lowered one of those lines, and it just kept going, past every depth they had ever recorded. They measured approximately 4,475 fathoms, around 26,850 feet, and the crew had no idea they were hovering above the edge of the deepest place on the planet. That spot was later named Challenger Deep in their honor, which is a pretty good legacy for a ship. For the next 75 years, the trench existed mostly as a theoretical extreme, an enormous number on a navigation chart. Then in 1951, the British survey vessel HMS Challenger 2 returned to the region with a far more sophisticated echo sounder. By bouncing sound off the seafloor and measuring the return time, the crew detected something that confirmed what the first expedition had hinted at. Their maximum recorded depth was approximately 5,940 fathoms, over 35,600 feet. The Challenger Deep had a name, and the science community had its first reasonably precise measurement. In 1957, the Soviet research vessel Vityaz reported a depth of 36,201 feet. In 1984, a Japanese survey ship using narrow multi-beam echo sounders returned readings around 35,140 feet. Each expedition sharpened the picture. By the time NOAA deployed hydroacoustic instruments in 2010, the technology had advanced enough to record 36,070 feet at the Challenger Deep. The 2021 pressure sensor, studied during Victor Vescovo's 5 Deeps expedition, settled on 35,176 feet as the most precise value to date, though scientists are still debating the exact number. And what is striking about all of this is how long it took just to measure the place, let alone explore it. For nearly a century after discovery, Challenger Deep was just a number on paper. The creatures living there, the geology of the floor, what it actually looked like down at the bottom of the world, all of it was completely unknown. The gap between discovery and actual exploration is one of the most humbling facts in the history of science. Which brings us to January 23rd, 1960, the date when something happened that no person had ever done, and remarkably, no one would repeat for over 50 years. Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh climbed into a bathyscaphe called the Trieste, which was essentially a pressurized steel sphere suspended beneath a large float tank filled with aviation gasoline, and they began descending into Challenger Deep. The dive down took approximately 5 hours. When they arrived, they were sitting at 35,114 feet below the surface, under a pressure of roughly 16,000 pounds per square inch. Piccard had helped his father Auguste design the Trieste, making the mission a kind of family legacy built on years of engineering work. The vessel was not built for comfort. It was not built for speed. It was built to survive, and it did survive, though not without a scare. During the descent, one of the outer observation windows cracked, shaking the entire vehicle. Piccard and Walsh looked at each other and made the decision to keep going. At the bottom, they made a discovery nobody had predicted. Through the porthole, in the sediment of the deepest point on Earth, they observed what appeared to be a flatfish, not a microbe, not a single-celled organism, but a recognizable, relatively complex creature. Later analysis debated whether it may have actually been a sea cucumber, but the significance was immediate and enormous. Life existed at the absolute bottom of the world, under conditions that many scientists had argued would be completely empty of life. The implications for biology, for our understanding of where life can exist, were staggering. Piccard and Walsh spent just 20 minutes at the bottom before beginning a 3-hour ascent back to the surface. Those 20 minutes represented the entirety of direct human observation at Challenger Deep for the next 5 decades. When they surfaced, Walsh reportedly told the crew waiting on the support ship that it was, in fact, the bottom. The record stood unchallenged for 52 years, which says everything you need to know about how demanding that dive remains even today. Then came March 26, 2012, and a name you might not associate with deep-sea exploration. James Cameron, the filmmaker behind Titanic and Avatar, piloted a one-person submersible of his own design, the Deepsea Challenger, to a depth of 35,756 feet in Challenger Deep, becoming only the third person ever to reach the bottom and the first person ever to do it alone. Cameron had spent years and significant personal funding developing the vertical torpedo-shaped submersible, which was designed to descend at around 500 feet per minute, much faster than the Trieste's pace. The whole vehicle was packed with instruments, sample collection systems, cameras, and lighting. Cameron had not just funded the project, he was involved in the engineering decisions. The dive was part of a program called Deepsea Challenger, in partnership with the National Geographic Society and Rolex. At the bottom, Cameron spent about 3 hours, significantly longer than Piccard and Walsh's 20 minutes. He described the environment as desolate and lunar, a flat and featureless plain of sediment. He found very few visible creatures during his time there. He collected sediment and rock samples before beginning the ascent. Later, Cameron donated the Deepsea Challenger to the Woods Hole Oceanographic Institution, and it was displayed outside the American Museum of Natural History in New York City in August of 2014. But beyond the record and the spectacle, Cameron's dive proved something crucial. Privately developed submersible technology could survive Challenger Deep, and that proof of concept would matter enormously in just 7 years, because then came Victor Vescovo. If Cameron went deep once and made international headlines, Vescovo went deep over and over and basically turned it into a scientific operation. A retired U.S. Navy officer and private equity investor, Vescovo completed what's known as the 5 Deeps expedition between 2018 and 2019, a mission to reach the deepest point in each of the world's 5 oceans. His submersible, the DSV Limiting Factor, a Triton 36002 built by Florida-based Triton Submarines, became the most capable deep-sea vessel ever constructed for repeated dives at full ocean depth. On April 28, 2019, Vescovo descended to 35,853 feet in Challenger Deep, setting a new depth record. That beat Cameron's mark by 97 feet. But the record is not the most important part. Vescovo dove into Challenger Deep 14 times over the course of the expedition, more than all previous dives combined at that depth. Each dive served a different scientific purpose, mapping the floor geometry, collecting biological and geological samples, deploying lander instruments, and demonstrating what sustained deep ocean research could actually look like. What he found on those dives was both extraordinary and deeply uncomfortable. New species of crustaceans were identified from samples. The floor was mapped in greater detail than ever before, but Vescovo also saw plastic waste at nearly 36,000 feet below the surface. A plastic bag, candy wrappers, human material that had no geological explanation, only a human one. That discovery made news around the world and became one of the most quietly devastating symbols of the global pollution crisis. And while Vescovo was doing those dives, scientists reviewing data from a NOAA hydrophone that had been lowered into the trench in July of 2015 were processing something equally striking. The titanium-encased recording device, designed to survive the pressure 7 miles down, filled its entire data capacity within 23 days. When researchers analyzed the recordings that November, the sounds included earthquakes, typhoons, the calls of baleen whales somewhere in the Pacific, and the propeller noise of distant ships. Even at the bottom of the world, the ocean is not quiet, and it is not untouched. The region below 20,000 feet is called the hadal zone, named after Hades, the Greek god of the underworld, and the name fits. No light, temperatures hovering between 1 and 4 degrees Celsius, just barely above freezing. Pressure exceeding 1,000 times what you are experiencing right now. And yet, life. Abundant, specialized, and in some cases, surprisingly large life. Sea cucumbers are among the most commonly observed animals in the hadal zone, often representing the majority of visible biomass on the deep sea floor. They crawl slowly across the sediment, consuming organic material that drifts down from the upper ocean. Amphipods, tiny shrimp-like crustaceans, are everywhere. One species called Alachella gigantea can reach up to 13 inches in length, which puts it firmly in the category of deep-sea giant. And these creatures are scavengers drawn to food sources with a speed and ferocity that routinely surprises researchers who deploy baited landers. Snailfish have been filmed deeper than any other vertebrate ever recorded, at around 27 to 349 feet in the nearby Izu-Ogasawara Trench. Cusk eels, which look like eels but are actually distantly related to tuna and seahorses, span one of the greatest depth ranges of any fish on the planet. The trench also hosts bioluminescent organisms and bacteria that survive entirely on chemical energy rather than sunlight. Microorganisms whose genetic adaptations researchers believe may eventually unlock breakthroughs in medicine and biotechnology. Then, in 2024, Chinese scientists aboard the research submersible Fendouzhe completed 23 dives into the Mariana Trench and found the deepest known animal community ever recorded. Thousands of worms and mollusks living at depths ranging from 8,200 to 31,000 feet, not isolated individuals. An interconnected ecosystem operating at the edge of what physics says should be survivable. And nearby, the Ifuku submarine volcano vents liquid carbon dioxide at 2017 degrees Fahrenheit, while the Daikoku submarine volcano sits above a pool of molten sulfur 1,145 feet below the surface, a phenomenon that exists nowhere else on Earth. The deep ocean is, among other things, completely incredible, and yet it is being contaminated. Here is one of the most uncomfortable facts in modern science. The Mariana Trench, the most remote and least visited location on the entire surface of this planet, is polluted. Microplastics have been detected in trench sediments and inside the tissue of deep-sea organisms living at full ocean depth. Persistent organic pollutants, compounds like PCBs and flame retardants produced by industrial manufacturing, have been found concentrated in amphipods collected from the hadal zone, accumulated through the food chain in a process called biomagnification. The pollutants go in at the top and get more concentrated the further down the food chain they travel. The plastic bag Vescovo spotted in 2019 was not an anomaly. Deep-sea landers deployed by research institutions have photographed plastic debris on the floor of Challenger Deep on multiple occasions. The depth record for plastic pollution, set at 35,754 feet, belongs to a single-use plastic bag observed during survey dives. Think about that for a moment. The deepest waste ever recorded is a bag. How does it get there? Some material sinks directly. Heavier plastics absorb water and descend over years and decades. Some is transported by organisms that consume microplastics in the surface ocean and then die, carrying those particles downward as they decompose. Ocean currents funnel debris from the massive rotating gyres, the floating garbage patches you may have heard about, and gradually move it toward the sea floor. The trench, by its geometry, acts almost like a drain, concentrating whatever the ocean delivers. And the scientific stakes are not just aesthetic. Chemical contaminants entering the hadal food web may disrupt biological processes in organisms we barely understand, in an ecosystem we have only just begun to document. If the deep ocean plays a role in carbon cycling, nutrient transport, and the regulation of surface ocean chemistry, which evidence increasingly suggests it does, then disrupting it has consequences that reach far beyond the trench itself. The trench is also not passive geology. It is an active system tied directly to the tectonic forces that drive volcanic eruptions, shape island chains, and generate some of the most powerful earthquakes ever recorded. The subduction process that created the trench is ongoing. It generates volcanic activity in the Mariana Island arc above the surface and releases trapped water from the subducting crust, which triggers flux melting in the upper mantle. Seismologists once thought the geometry of the Mariana subduction zone made major earthquakes unlikely because the dense Pacific plate was thought to not generate enough friction against the overriding plate to build serious seismic stress. Then the 2004 Sumatra earthquake and the 2011 Tohoku earthquake in Japan, both in similar subduction settings where major quakes were also considered unlikely, forced a revision. Geophysicist Emile Ocal stated that there is no reason the Mariana region could not produce a magnitude 8.5 earthquake. Historical records document tsunami-generating events in the region in 1826 and 1872. The subduction zone also sits at the center of a growing conversation about deep-sea mining. Hadal zones and hydrothermal vent fields associated with trenches are rich in rare earth elements and polymetallic nodules. Nations and private companies have increasingly discussed extracting these resources as demand for battery metals rises with the global energy transition. Scientists and conservation institutions have pushed for a pause on deep-sea mining, citing the irreversible damage it would cause to ecosystems that took millions of years to develop and that we have only just started to understand, which leads to the most staggering statistic in all of ocean science. We have mapped more of the surface of the Moon and even Mars than we have of Earth's own ocean floor. As of the most current surveys, over 80% of the ocean remains unobserved at any meaningful resolution. We have explored less than 5% of the total ocean volume. For a species that calls itself highly intelligent, we have a remarkably shallow understanding of the planet we actually live on. Fewer than 30 people have been to Challenger Deep. More than 7,200 people have stood on top of Everest. A deep ocean submersible capable of reaching full ocean depth costs tens of millions of dollars. The operational complexity, life support, pressure engineering, navigation, and recovery logistics rivals a crewed spaceflight. The ocean is, in practical terms, harder for humans to access than low Earth orbit. The next generation of deep ocean exploration is increasingly international. The Chinese Fendouzhe program, NOAA's continued exploration mandates, private expeditions following the 5 Deeps model, and improved autonomous underwater vehicle technology are all converging to close that knowledge gap. In the coming decade, scientists expect to map the full floor of Challenger Deep at high resolution, identify hundreds of new species from hadal samples, and develop a much clearer picture of how trench ecosystems participate in the global cycles that regulate life on the surface. There is also a conversation about protection that needs to happen faster. The Marianas Trench Marine National Monument covers significant surface area, but excludes Challenger Deep itself. International agreements governing research access are a patchwork. As the trench becomes more accessible and commercially interesting, the regulatory frameworks around it are going to need to catch up quickly, or the damage will outpace the science. 7 miles, 30 human visitors, 150 years of science, and we have barely scratched the surface, or in this case, barely scraped the bottom. The Mariana Trench is a window into what Earth looked like before we arrived, what life is capable of enduring, and how far our presence on this planet has already reached into its darkest corners. A plastic bag at 35,000 feet is not a footnote. It is a message, and it is one we sent to ourselves. What this trench keeps teaching us every time we send something down there is that we fundamentally underestimate our planet, its depth, its resilience, its complexity, and its fragility, all at the same time. The amphipods and the snailfish and the thousands of worms living in their impossibly deep colonies did not ask to share their world with our waste, but here we are. If this video gave you something to think about, hit that like button. We are going deeper on ocean science, extreme environments, and the frontiers of exploration that most channels never get near. Turn on notifications, so you do not miss what is coming next. Thank you for watching and for caring about what is happening 36,000 feet below the surface of the world you live on.